Good day, everyone. Today we have a lot of topics to discuss because we will be tackling about preliminary concepts in calculus. Now, this means that we will be discussing concepts that are very, very essential before we move on to the concepts in calculus. Although these topics were already discussed in high school, but again, to understand easily on the concepts in calculus, we have to discuss this first, okay?
So here we are going to discuss on the domain of the given function. So we are going to identify the domain or to find the domain of the given function. By just looking at this graph, um, we clearly see that this set here, the set of input values or the set of x's, is what we call the domain, and the set of the y values is what we call the range. So the set of all inputs for the function is again what we call the domain. And explicitly, if we are given a function, then the domain is specified. For example, f of x is equal to x squared, and x is less than or equal to 7, but greater than or equal to 2. So we describe this function explicitly because the domain is clearly described here that it should be in between 2 and 7 only. Okay. Now, implicitly, the set of all real numbers. The domain is the set of all real numbers for which the expression is defined as the real number. So it says here that implicitly, the domain is the set of all real numbers that can make the function defined. For example, f of x is equal to 1 over x minus 5. So implicitly, we are going to find all the values of x that can make the function defined. Now, since this function, it's very clear that this is not defined if x is equal to 5, right? Because if x is equal to 5, the denominator will be 0 and the whole expression will be undefined because we have a function value which is 1 over 0, so undefined. Thus, the domain of this given function is x, such that x is not equal to 5, or it means that x such that x is in the set of real numbers such that x is not equal to 5. So all real numbers except 5. That's the domain because it's the set of the the values that can make the function defined. Another example, we have f of x is equal to the square root of x minus 2. Now, we have to take note that this expression here or the equation, this is not defined if x is less than 2. Because if x is less than 2, the radicand, okay, the value inside the radical symbol will become negative, right? And if it is negative, that means we can have an imaginary number, so we cannot have a real number, exact real number. Therefore, in the real number system, this one is not defined if x is less than 2. For example, is if x is 1, for example, then we are going to substitute 1. So we can have square root of 1 minus 2, which is square root of negative 1, which is not a real number. Therefore, but it is defined if x is greater than or equal to 2. For example, if x is equal to 2, this will be x is equal to square root of x minus 2 is equal to what? 2 minus 2 is 0, so square root of 0 is 0, so it's a real number and it is defined. If x is equal to 3, for example, square root of 3 minus 2 is equal to 1, so we have square root of 1, which is equal to 1. It's defined. Therefore, the domain or the set of all values that can make the function defined is x such that x is greater than or equal to 2 only. Or this is, since we are using braces here, this means that this is a set. The set of x such that x is greater than or equal to 2. So that's the domain. So um, we have here some basic examples of functions and their domains. So um, to know the functions, the domain of the functions, which are quite complicated, we have to know first the basic functions and its domain. For example, all polynomial functions. What's the domain of a polynomial? Actually, this is already a theorem, so do not worry. Uh, Although, if you want to prove this one, there are a lot of proofs out there. So all we have to do is just only to follow this theorem. All polynomial functions, the domain of any polynomial is the set of all real numbers. So for example, if f of x is equal to x squared plus 2x plus 1, it's a polynomial, right? So therefore, we can immediately say that the domain of that function is the set of all real numbers. But how about f of x equal to square root of x? Now, for the square root of x, the domain is x greater than or equal to 0, because if x is less than or equal to 0, this will be undefined, or we can have an imaginary number, so which is not a real number anymore. So um, for us to be for us to know the domain of the functions, which are quite complicated, we have to take note of these. So what's the domain? X is in R such that x is greater than or equal to 0. Now this is, we describe the set using the set builder notation, but we can also write as interval notation. So using the internal interval notation, we can also describe the function. Okay, take note of this basic function, because when we move on to something which is not only x, it will become easier for us to solve that kind of problem, because we are already master on the basic functions and its domain. Now, how about f of x is equal to 1 over square root of x? Then the domain of that is x in R such that x is strictly greater than 0, which is written also like this. Okay? You have to take note, because if we equate that one to 0, we can have 1 over square root of 0, which is 0, so we can have 1 over 0. That means if x is equal to 0, the function is undefined. How about 1 over x? 1 over x, so the domain, take note, if it is a rational function, we have to take note that the domain is the set of values that can make the function defined. So if it is rational, we have to look at the values in the denominator, and that will be exempted in the set of domain. For example, if x is equal to 0, this will be undefined. Therefore, the domain is x in R such that x not equal to 0, or sorry, or using the interval notation, this is negative infinity to 0, union 0 to positive infinity. How about the absolute value of x? The domain of this absolute value of x is equal to R, or the set of all real numbers. Okay, so to understand more, we have here an example on finding the domain of the given function. For example, let f of x is equal to square root of 3x minus 2. Now find the domain of the given function. Again, we have to take note um, the basic functions that we had earlier. So since it's like a basic function which is a radical, right? Um, or the square root function. So this is square root of 3x minus 2. So what are you going to do is that you have to base that one to the basic function, which is square root of x, right? Now, the domain of the square root of x is x greater than or equal to 0, which means that whatever the radicand inside here in this radical symbol, it should be greater than or equal to 0. So um, instead of x, we are now using the radicand. The whole radicand, which is 3x minus 2, should be greater than or equal to 0. Okay? So again, by following the basic function in number 2, the radicand must be greater than or equal to 0 for the function to be defined. So this is how we solve the domain. Since this one will be defined if the radicand is greater than or equal to 0, so we write this one as like this. 3x minus 2 greater than or equal to 0, then you solve for x. So this is equal to 3x greater than or equal to 2 and divided by 3 because we want to know the values of x that can make the function defined. So x is greater than or equal to 2 over 3, which means that if x is equal to 2 over 3, okay, 2 over 3, this will be square root of 2 minus 2 square root of 0. It's defined. Okay. But how about if x is not in the domain? For example, if x is equal to what? If x is equal to um, 0, for example, if x is equal to 0, okay, if x is equal to 0, so this will be 3 times 0 minus 2. So we have square root of negative 2, which is not a real number. That's why it's very important to know on how to find the domain of the given function. So what is the domain? The domain is the set of all uh, x in the set of real numbers such that this inequality holds, such that x is greater than or equal to 2 over 3, which can also be written as like this. Interval notation 2 over 3 up to the positive infinity. So this is how we identify the domain of the given function. So hope you like this video and don't forget to share the learning that you got from this video. Thank you so much. And for our next topic, by the way, if you want to know, if you want to practice more, we have here practice problems. Okay, um, you can show your answer in the comment section. Okay. Oh, so this is the practice problems. So once again, thank you so much. And for our next topic, it will be operations and functions. Okay, thank you and bye bye.